Bismillahirrahmanirrahim. Today is 12th of September 2020. Class is 9th, subject science, and today's topic is universal law of gravitation. We know that there exists force between two objects and anywhere. If there are two objects and always exists force between them. According to universal law of gravitation, every object in the universe attracts every other objects. That means every object attracts other objects with a force. It will attract. That means there should be a force for attraction. So uh, every object will attract other object with a force which is proportional. That force is proportional to the product of their masses. That force is proportional to the product of their masses and inversely proportional to the square of the distance between them. Whatever the distance between the objects is, that force is inversely proportional to the square of the distance and directly proportional to the mass of the objects. So this is universal of law of gravitation. That is यहाँ ये कहना चाहता हूँ कि दो ऑब्जेक्ट्स के दरमियान फोर्स ऑफ अट्रैक्शन मौजूद होता है, और जो फोर्स ऑफ अट्रैक्शन उनके दरमियान है वो डायरेक्टली प्रोपोर्शनल है टू द प्रोडक्ट ऑफ देयर मासेस. यानी कि दो ऑब्जेक्ट्स के मास के प्रोडक्ट्स के बराबर वो फोर्स होता है, और इनवर्स प्रोपोर्शनल होता है टू द स्क्वायर ऑफ द डिस्टेंस बिटवीन दी. इनके दरमियान जो डिस्टेंस है उसके स्क्वायर के इनवर्सली प्रोपोर्शनल होता है. तो अगर हम दो ऑब्जेक्ट्स लेते हैं ए एंड बी, यहाँ पे मैंने डायग्राम बनाई है और इनके दरमियान मैंने डिस्टेंस डी दिखाई है. एंड बी आर टू ऑब्जेक्ट्स and they are having masses. I have shown this mass by capital M and the mass of other object by small m. So I have taken two objects, that is A and B, and the distance between them is D. Their masses is M and M. So according to the law, F should be equal to G into M. This is the mass of this object, this is the mass of this object, and divided by D square. And G is gravitational constant. And every object in the universe attracts every other object with a force. एक फोर्स से अट्रैक्ट करता है which is जो होता है proportional to the product of their masses. proportional होता है उनके मास के प्रोडक्ट्स के बारे में बराबर, and inversely proportional to the square of the distance between them, और inversely proportional होता है to the square of the distance between them. यहाँ से यहाँ तक जो distance है वो है d. This is inversely proportional, I have written here, and directly proportional होता है m into m. So this force is directly proportional to product of masses and inversely proportional to the distance, square of the distance between them. The force between the two objects is directly proportional. जैसे यहाँ पे इस लॉ में हमने कहा कि फोर्स जो होता है ऑब्जेक्ट्स के दरमियान वो डायरेक्टली प्रोपोर्शनल होता है टू द प्रोडक्ट ऑफ देयर masses. So we will write F directly proportional into m into m. I have represented capital M for the mass of this object, that is object A, and small m for the mass of object B. So F force is directly proportional to the product of masses. So I wrote here m into m, directly proportional to m into m. This is equation first. We will get now. We also know that force is inversely proportional to the square of the distance between the force between two objects is inversely proportional to the square of the distance between them. So we will is directly proportional to 1 by d square. That is force is inversely proportional to the distance square of the distance. Combining equation first and equation second. Combining equation first and second, we will get f is common, f equal to f directly proportional to m into m divided by d square, divided by d square. So f will be equal to g into m divided by d square, while this g is universal constant, uh, which is called gravitational constant. G is universal constant. Which is called gravitational constant. So G is constant of proportionality or universal constant, which is called a gravitational constant. Crossing this, crossing here, we will get f d square is equal to g into m into m. So g is equal to f d square divided by m into m. G can be obtained by applying the values of force, distance and mass, or standard SI units, by applying the SI units of these units. So the SI unit of G can be obtained by substituting the units of force, distance and mass. So applying the units of force, distance and mass into this equation, suppose this is equation third, we will get the SI unit of G. So it will be, we know the unit of force is Newton, distance will be meter square, and the unit of mass is meter square kilogram, but it is on the below this, so this will be kilogram per kilogram, Newton meter square per square kilogram, This will be the SI unit of G. So substituting this, G was obtained by a scientist named Henry Cavendish. Henry Cavendish obtained the numerical value of G. Obtained the numerical value of G, and that was equal to 6.673 into 10 raised to power 10 raised to minus 11 Newton meter square per kilogram square This was Henry Cavendish who obtained the numerical value of G, and numerical value of G is equal to 6.673 multiplied by 10 raised to minus 11 Newton meter square per kilogram square. Thank you. This was all about universal law of gravitation, and we saw that the force of attraction between two objects is directly proportional to the mass, or to the product of the mass of the two objects, and inversely proportional to the square of the distance between them. After putting the values of these force and distance and mass into this equation, we got the value of G. That is, G is here universal gravitational constant, and the value of G was then obtained by Henry Cavendish by by putting various numericals, and the value of G is equal to, he got was 6.673 into 10 raised to minus 11 Newton meter square per kg square. Thank you.